This concept is a little bit harder, so it's going to take a little bit longer. I'll try to stay under 10 minutes, though. So when we are making models, the biggest problem that I've ever seen is how do I even make the stinking equation? Okay, there's a couple of steps that you can follow that can make the equation easier to find. Step 1, what is the question asking for? So this requires you to go back through the word problem and see what shapes do I actually need to use. Step 2, find the formulas for that perimeter or area or volume that you are asked to find. If you don't remember them, then find them from somewhere, a formula chart, Google, something. Step 3, set up the restraint equation, and we'll get to what that is in a little bit. Step 4, use the restraint to actually make the model equation. And step 5, use algebra to solve for the answer. So for the first example, you are in charge of making a lunging ring for a horse trainer. There are no restrictions, but you are asked to find a formula to describe the area of the ring based on the amount of fencing that it will take to enclose it. So first, what is the question asking for? The problem says ring, so I can assume that I'm dealing with a circle. It also says area, and it says fencing. Okay, now fencing goes on the outside, so that must mean circumference. So I need the formulas for area and the formula for circumference. Now notice that I'm starting with a picture. This is important. I'm dealing with shapes, so I draw a picture. This actually ends up making my life a lot easier. I suggest you do the same. So here's my two formulas. And since both the formulas have radius, we're going to solve the circumference for radius first, and then substitute it back into area. So we got to divide both sides by 2 pi, then take that and plug that back into the area formula. After we plug it back in, it just takes a little bit of algebra to simplify it, and we get the answer. Do a little bit of cancellation. And there we go. Simple. Now, I know a few of you, at least, are thinking, well, you know, we know Mr. Ellermann, and Ellermann is just going to show us the easy one and then make us do the hard one for homework. And you'd be right. That's exactly what I'm going to do. But instead of leaving you hanging dry, let's look at one that is a homework problem. So for the second example, your boss has asked you to mark the volume of a conic container, conic means cone, based on the depth of the merchandise inside. So conic, well, hold on, first, we're going to need the volume, and it also says conic, so that means we're dealing with a cone, and it also says depth. So these are the three things that I need to know. I need to know the volume, I need to know the volume of a cone, and I need depth or height of that cone. So let's start with our picture. And let's go ahead and say the radius of this cone at the very top is going to be 4. Let's say 4 feet. And the total height of this cone is going to be 10 feet. Looks like my picture messed up. It'll get there in a second. There we go. 10 feet. Now, as you can see what I've drawn on here, you can make a right triangle by drawing it into the picture. I can use this idea to justify using similar triangles. Now you're probably thinking, where in the world did he figure out to use a right triangle? And the answer is, it's called the KISS method. And KISS, K-I-S-S, is an acronym. It stands for Keep It Simple, Silly. And so when you get stuck on a shape-based modeling problem, draw a picture and pick out the easiest shape you can see. For me, that easiest shape is a triangle. So that's why I went with a right triangle. And this will usually get you unstuck. Now, since I'm using similar triangles, I can remember from geometry that the ratios must stay the same. So r divided by h must be equal no matter where I am. Therefore, I'm going to set up an equation with r and h on one side and my maximum radius and maximum height on the other side. Now I just solve this equation for r and put the result into the volume formula. So moving the volume formula over so you can see what I'm doing. I'm going to make my substitution. Now that I have that substituted in, all I have to do is a little algebra. And I'm done. Now, does it look pretty? No. And your model formula will not always look pretty. And that's got to be something we get used to. All right, so try this one on your own, and then play the rest of the video to see how I worked it. Pause it before you get started, and then when you're finished, you may play the video to check how I did it. All right, take a minute and figure it out. All right, so this is how I tackled it. I first realized that I needed to find volume, so I started with the volume formula. And I also was asked to do circumference, so I started with the circumference formula also. Since both of them have radius, I solved the circumference formula for r and took my radius formula and plugged that, or substituted that, back into my volume. Do some simplification. And some cancellations. And I'm done. Now the final step for this problem, and I forgot to do it here, would actually be to substitute the 4 feet for the length of this cylindrical barbecue pit in for h. And if I did that, I could actually simplify this even further to 1 over pi times c squared. And that would be the end of it. All right, so that's the end. Remember the steps. First, what does it want? Second, what are the formulas? Third, find the restraint, which are the values that are included in the problem. Fourth, make the model. And fifth, solve. So I kept it just under 10 minutes. Sorry, I'll try to make this a rare occurrence. See you tomorrow.